With about 15 lines of Python, you can scan an entire Bitcoin block, every single transaction, every single output, and discover that over 10,000 BTC moved through it. Right? Your Bitcoin node already has all of this data sitting right there, waiting for you to ask the right questions. The way you ask is through a protocol called the JSON-RPC. Today, we go from raw HTTP calls to real programs that command your Bitcoin node. JSON-RPC has two halves. JSON, JavaScript object notation, is a lightweight data format. Curly braces, key value pairs. RPC stands for remote procedure call. You send a function name and arguments over HTTP. The server executes it and returns a result. Combined, your code sends a JSON formatted function call via HTTP post to Bitcoin core and gets a JSON formatted answer back. Here's the key insight. bitcoin-cli, the command line tool, is just a thin wrapper around this same protocol. When you type bitcoin-cli get blockchain info, the CLI reads a cookie file, formats a JSON RPC request, sends it to localhost port 8332, and prints the response. Your Python script will do the exact same thing. Let's see JSON RPC at its rawest level, a curl command. Right? Here's the structure, curl --user with the cookie credentials that Bitcoin Core generates on startup, then --data binary containing the JSON payload. That payload has 4 fields, JSON RPC set to version 1.0, an ID for request tracking, the method, here, get blockchain info, and params, an empty array since this method takes no arguments. The target URL, http://127.0.0.1:8332. Fire it off, and Bitcoin Core returns a JSON object. Inside the result field, chain name main, current block height 840,000, verification progress, and more. Every RPC method follows this exact pattern, same structure, different method name, different params. That curl command works, but nobody wants to craft raw HTTP for every call. Libraries handle the boilerplate. Install python-bitcoinlib with pip. Here's the minimal script. First, import AuthServiceProxy from the bitcoin-rpc.authproxy module. Next, build the RPC connection, URL, http:// your RPC username, password, @127.0.0.1:8332. Create the proxy object RPC equals AuthServiceProxy with that URL. Now call rpc.getBlockchainInfo, parentheses, no arguments. The library handles the HTTP post, JSON serialization, authentication, and response passing automatically. Store the result, print result, bracket quotes blocks, run the script. A single number appears, 840,000. That's your node's current block height, retrieved programmatically. Simple, but this proves the entire pipeline. Your code connects to your node responds with verified data. No block explorer, no third-party API. Getting the block height is a proof of concept. The real power appears when you chain calls together. Let's decode a real transaction. Same setup, import connect, provide a transaction ID, that 64-character hex string that uniquely identifies every Bitcoin transaction. Call rpc.getRawTransaction, passing the TXID and a 1. That second argument tells Bitcoin Core to return decoded JSON instead of raw hex. The response is a rich dictionary. Inputs, outputs, version, lock time. Focus on the outputs, the vault field, which is a list. Loop through it. For each output, extract the value field for the BTC amount and dig into the script pubkey dictionary to find the address. So print both. I run this script and the 2 lines appear. First output, 0.015 BTC to 1 address, the payment. Second output, 0.00032 BTC to a different address, the change returning to the sender. 2 RPC calls decompose the Bitcoin transaction into its economic parts. The pattern, call a method, navigate nested JSON, extract what matters. Now the climax example, we scan every transaction in a block and sum all output values to find total BTC moved. Start with a block hash, the hex identifier for block 840,000, Call rpc.getBlock with that hash. The result includes a TX field, a list of every transaction ID in the block. Block A40,000 contains roughly 2,500 transactions. Initialize a variable total to 0. The outer loop iterates through every transaction ID in that list. For each one, call rpc.getRaw transaction with the TXID and verbose flag 1. Inside each decoded transaction, run an inner loop through the vault list. The outputs, each output has a value field in BTC added to the running total. That's the entire script. 2 nested loops, 1 extra RPC call per transaction. Run it. The script takes a few seconds, making over 2,500 individual RPC calls, fetching each transaction, summing every output. The result, 10,247 BTC. Over 10,000 Bitcoin moved through a single block. A task impossibly tedious by hand takes seconds with a short script. Your node verified every byte of that data. A quick note on authentication. Bitcoin Core generates a .cookie file in its data directory each time it starts. This file contains a randomly generated credential pair. python-bitcoinlib can read this file automatically. Alternatively, set static credentials in bitcoin.conf using rpcuser and rpcpassword. For long-running scripts, static credentials are more reliable since the cookie regenerates on every restart. Now, Python is just one option. JSON-RPC speaks HTTP and JSON universal protocols. Libraries exist across the developer ecosystem. JavaScript offers Bitcoin, Bitcore, and Bitcoin.js. Java has Bitcoin.j, Go has BTCD, Rust has Rust Bitcoin, C# has mBitcoin, Scala has Bitcoins. Bitcoin Core itself is C++. Whatever language you work in, a maintained library connects you to your node. The underlying protocol is always the same. HTTP post in, JSON response out. Here's why all of this matters. When you query a block explorer, you trust that company's servers, their software, their data integrity. When you call a third-party API, you trust their infrastructure and their version of the truth. When you run your own node and query it with your own code, the trust model collapses to 0 external dependencies. Your hardware stores the blockchain. Your node validates every block against consensus rules. Your code extracts exactly the data you need. No intermediary can censor, modify, or delay your access. This is the foundation of financial sovereignty, and it's built on a protocol as simple as an HTTP post. Your node, your code, your verification, no trust required,